Welcome to MIPI DevCon 2020. Thanks for joining. We're glad to have you with us today. Feel free to engage with the presenters and attendees by using the engagement tools at the footer of your screen. Click Q&A to engage with presenters and group chat to communicate with the attendees. You can simply minimize or maximize each of these icons with one click. To see the agenda, sessions, and demos, click on the Call to Action icon. Enjoy the conference.
As the MIPI, CFI, and DeFi links get deployed in more bandwidth-intensive applications, they require more advanced test systems for the purposes of characterization, design validation, and production testing. Hitting the data rates that are mandated in the CFI version 2.0 and DeFi version 3.0 specifications requires very high bandwidth, sophisticated signaling technologies, and highly complex system-level and protocol features. And when it comes to testing such links, traditional solutions are often very challenging. For example, traditional receiver test setups require complex equipment arrangements, and they suffered from challenges with measurement uncertainty and getting repeatable stressed eye test results. Introspect has pioneered MIPI receiver testing with the SV3C product line, and we are now proud to introduce our new Introspect SV5C DPTX-CPTX Combo MIPI DeFi and CFI generator. In a single handheld instrument, this generator offers double the bandwidth of the Introspect SV3C solution. It increases the memory depth, and it provides an even expanded impairment generation system. Featuring a completely new analog front end and an updated software environment, the SV5C DPTX-CPTX Combo MIPI DeFi and CFI generator acts as a sophisticated waveform generator capable of performing complete receiver CTS testing without requiring external equipment, acts as a pattern generator for performing CSI2 or DSI2 CTS testing, again without requiring external equipment, and acts as a complete video source capable of streaming CFI and DeFi data at the highest possible bandwidths. In this demo, we connect the SV5C DPTX-CPTX Combo MIPI DeFi and CFI generator to different pieces of equipment to showcase its capability. As can be seen, the most important hallmark of the solution is that it is completely integrated. It contains the LP pattern generators and their corresponding voltage drivers. It contains the HS pattern generators and their analog front end. It contains all impairment signal sources such as delay generators, jitter injection circuits, and voltage noise sources. In this connection, we show the A, B, and C wires of Trio 1 connected to the scope. As we will see, each wire contains its own parameter controls and its own impairment sources. Control for the parameters of the SV5C DPTX-CPTX MIPI DeFi and CFI generator happens through the award-winning Introspect ESP software shown here. The software strikes a perfect balance between ease of usability and infinite programmability. On one hand, as I show here, all parameters of the generator are available in tables that enable one-click generation of signals. For example, the instrument itself is represented by the MIPI Generator class, and this class has a list of attributes related to things like voltage levels or wire skews. Most importantly, the MIPI Generator calls two other classes. One for the pattern, where I can select preset PRBS patterns like I show here, or create my own CSI and DSI video sequences. And the other component is the parameters one, where all physical layer specifications are controllable. If I go ahead and click Run on this setup, without writing any code, you can see that I instantaneously observe the output of the generator on the scope. Similarly, I can go ahead and change the HS voltage amplitude, and we will see how each individual wire is programmable. As you can see on the scope, I have reduced the amplitude of wire A and clicked Run, and then I will bring it back to nominal and click Run again. Of course, this is a simple illustration for what we refer to as on-the-fly programmability. This is a concept that is extremely important, and it is one that allows for incredible time savings when performing automated receiver testing. For example, I will now show a couple of loops in which all LP and HS signaling levels are adjusted in matters of seconds, let alone minutes. The first thing we see happening are the LP low values being shifted, and then the LP high. Next, the HS common mode is being shifted. And finally, the HS amplitude is being shifted. Just like voltage, the timing parameters can all be adjusted primarily through the params component I show here. I will now run a small automation loop in which the T3 pre-begin period is adjusted repetitively in real time. As you can see, I'm purposely playing a short packet in this example, and in every iteration of the loop, the length of the packet is increased because the number of 333 symbols is increasing. Incidentally, if I go back to the GUI in the Params tab, you can see that we support ALP mode. Additionally, if I go to the CSI image pattern component, we can enable all options of the EPD mode. If I select true, the GUI shows options related to EPD, such as number of spacers. Moving on to the high-performance aspect of the SV5C DPTX-CPTX, I will now show eye diagram performance. Starting at 2.5 gigasymbol per second, you can see how sharp the eye diagram is. The signals are characterized by sharp, linear responses, and they settle to the final value within only 50 picoseconds. Then as I go to 3.5 gigasymbol per second and then 4.5 gigasymbol per second, you can see how wide the eyes are and how stable the signals are. I am now setting 6.5 gigasymbol per second. Having such stable signal generation capability gives confidence in the receiver measurements being performed, and it ensures strong repeatability and reproducibility. More importantly, we can also add impairments to these signals, thus giving us a platform for accurate and precise stressed eye generation. Here I will go back to 3.5 gigasymbol per second, which is a common data rate for some high-end applications in the marketplace now. Then I will periodically adjust the eye opening through ISI injection, and I will do this in real time and without using any external equipment. I am sweeping through a handful of settings now, and in each step I will clear the scope to show you how the eye shape has changed. As you can see, I am able to start from a pristine eye diagram and gradually degrade it through simple software commands. The SV5C DPTX-CPTX supports CFI 2.0 and DFI 3.0 receiver CTS testing. As is well known, an important part of CTS testing is the stressed eye test. For this test, it is important to calibrate the receiver signal through a closed-loop connection to an oscilloscope. Through using the Introspect ESP software, the SV5C DPTX-CPTX comes with optional automated calibration routines for the stressed eye test. I will show here a time-lapse video to show how the eye diagram is optimized before performing CTS testing. This concludes our demo today. Thank you for attending it.